Okay, so I left you to answer these questions at the end of the last video. So I want to make sure that you understand that this is where we are for each one of these. Is there a greatest common factor? No. How many terms? There are two. Is this the difference of two squares? Yes. How do we know? That's a perfect square, that's a perfect square. Then this is explaining to you how it's going to factor. Remember, a squared is a perfect square because it's the result of saying a times a. B squared is also a perfect square because it's the result of saying b times b. So they're explaining to you that the way you factor the difference of two squares is, and you can put this here, DOTS, dots, difference of two squares. The way you factor that is, if you have an a squared, the root of a squared is a. Put an a in one parentheses and you put an a in the other parentheses, then the root of b squared is b, so put the root here. Okay, and then you put a plus sign in one and a minus sign in another because you have to have a positive times a negative to get a negative b squared. So a positive b times a negative b. So that's how they factor. So this would be the root of x is x. The root of 9 is 3. A plus 3 and a minus 3. Is it okay if you put x minus 3 times x plus 3? Yes. The order in which you put the plus and the minus doesn't matter here. So the root of x squared is x. The root of 36 is 6. Plus in one, minus in the other. The root of x squared is x. The root of 100 is 10. Put a plus in one and a minus in the other. So that's how simple it should be to factor the difference of two squares. If you end up with, let's do 3x squared minus 300. Okay, you have something like that. Step number 1, factor out a GCF. Can we factor out a GCF? Yes, we can. We can factor out a 3. That'll leave me x squared minus 100. Remember, this is 3 times 1. This number right here is 3 times 100. 3 is the common factor, so it comes out, leaving me 1x squared minus 100. Now that we have the GCF factored out, now we pay attention to the coefficients. See, so now we're over here. Did it have a greatest common factor? Yes, it had a greatest common factor. So factor out the GCF. So we factored it out. How many terms are they talking about in the quotient right here? How many terms were left in the quotient? So there's the GCF, and here's the quotient now. How many terms were left? 2 terms were left. Is it the difference of two squares? Is this right here dots? And the answer is yes. Then you keep the greatest common factor right there, and then you factor that out the same way you would if it didn't have one. X plus 10, x minus 10. And this would be the complete factorization of this one right here. Okay, so even if you say yes, you can factor out a GCF, you still, after you take the GCF out, you then go with the quotient, that's the part that's left inside there, and how many terms does it have? If it has 2, is it the difference of two squares? Now, be careful down here. Don't forget about this. I told you that the sum and difference of two cubes, we'll do those later, but the sum of two squares, so in other words, x squared plus 100, that's not factorable. Not with real numbers. It's actually factorable, but we'll learn how to factor it with imaginary numbers when we learn imaginary numbers. But the sum of two squares, the sum of two squares, SOTS, that's not a thing, not factorable. Okay? Not factorable. Let's see. I'm going to go ahead and I'm going to pause this. Okay, so now I'm going back to the problem where we are at 3 terms. What happens if we have 3 terms? The first question you're going to do is ask yourself, is it a perfect square? So perfect squares should be easy to recognize because notice right here they're telling us that the first term is a perfect square and so is the last term. So in other words, you're going to see something like x squared. This says that you might see a plus, you might see a minus, so that second term could be a plus, it could be a minus. I'll do an example of both. We'll put that, I'm going to leave that blank for just a second. But the last term will always be a positive and it will be a perfect square. So remember those perfect squares that we made the list of a while ago? Let's do 9. So I first quickly notice in this trinomial that this first term is a perfect square because remember it has an even exponent, so it's a perfect square. And then the last term is a perfect square. 1, 4, 9, 16, 25, 36. Y'all remember that list? This is 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. I'm not going to go on, but you remember that. So I recognize this is an even number. This is a perfect square. That by itself is not enough. In order to be a perfect square, this middle term must be the product of the root of this one and the root of that one times 2. The root of x squared is x. The root of this is 3, and 3 times x times 2 will give me 6x. This says the root of the first one, that's the x part, the root of the second one, that's the 3, and then we've got to multiply it times 2. Okay, so that is a perfect square. That is going to factor, and it's always going to factor the root of the first one, which is x. This sign, whatever this sign is, will match this sign. And then whatever the root of this one is will go here. Okay, so first of all, recognize that it's a perfect square. First of all, recognize that it's a perfect square. Is it a perfect square? This is a perfect square. This is a perfect square. And this right here is the root of this one, x, times the root of that one, 5, times 2. 2 times a times b. The root doubled. You with me? So that's how I know that's a perfect square. So is this a perfect square? Yes. Is this one a perfect square? Yes. This one's perfect square? Yes. So how does this factor? The root of that one is x. Keep that sign, whatever that sign is, and then the root of that one. Okay? Is this a perfect square? Some of you are quickly going to say, that's a perfect square because it's x squared. That's the number over here, so yes it is, but no it's not. This one's not a perfect square because this term right here messes it up. Because remember, this is supposed to be the root of that one times the root of that one times 2. See right there? The root of the first one times the root of the second one times 2. So that needs to be, if this had been x squared minus 8x plus 16, now it would be okay. And how would that factor? X minus the root of that is 4 squared. Or, of course, you could write x minus 4 times x minus 4. Okay? Recognize it if it's a perfect square. I'm going to do one more example using the flowchart. So let's do 3x squared plus 18x plus 27. Step number 1. Greatest common factor. Factor out the greatest common factor. Does this have a greatest common factor? Are all of these divisible? Is there something I can factor out? Yes, I can factor out a 3. This is 3 times x squared. This is 3 times 6x, and this is 3 times 9. So what do they all have in common? A 3. If I take that 3 out, I get x squared plus 6x plus 9. Okay? Greatest common factor. Yes, factor it out. Now ask the question about the quotient. How many terms does the quotient have? The quotient has 3 terms. Is it a perfect square trinomial? Perfect square, root times 2. This is 3 times 2 times x. So this is the root of x squared. This is the root of 9. So 3 times root times 2. So yes, this is a perfect square. Yes, it's a perfect square. Then how does it factor? 3x plus the root of that one is 3 squared.